Not everyone does. I mentioned that there will be a perfectly elastic collision problem, one-dimensional perfectly elastic collision problem on the last test. Whichever technique really seems to speak to you, learn that one. The biggest trouble I have students do is they start mixing and matching. They take a little bit of this technique, a little bit of that technique, a little bit of that technique, and that usually ends up a mess. So pick one of them, learn it. Just so that you can test yourselves. So if I had a 4 and a 10, so if I had a 4 kilogram mass heading to the right at at 6 meters per second, and then I had a 10 kilogram mass heading to the left at 1 meter per second. So the velocities are opposite sides. If it's a perfectly elastic collision, that 4 kilogram mass afterwards will be going to the left at 4 meters per second, and the 10 kilogram mass will be heading to the right at 3 meters per second. I'll give you one more that you can, so at home, this is problems so that I give you the problem, the answer, so that you can check whichever method that you're trying to learn. And then, I guess I'll take this one right here. So if I have a 3 kilogram mass heading to the right at 4 meters per second, 6 kilogram mass, a 1 kilogram mass heading to the left at 6 meters per second. That's before, in a perfectly elastic collision, the 3 kilogram mass is heading to the left at 1 meter per second after the collision, and the 1 kilogram mass is heading to the right at 9 meters per second. So you got two problems with solutions, assuming I didn't write something down wrong. I'm just double checking here. So we got 3, 4, 1, 6 heading towards each other. Afterwards, they are going apart. So I got 1 and 9. All right, and over here, that was the 4 and 10. So 4 going at 6, 10 going to the left, 1. And we end up with, just double check that answer there. So 6, negative 1. 14 divided by, so that's 1, subtract 1, 5, negative 2, negative 5, 2, add 1, negative 4, and 3. Yeah, okay. Okay. Yeah, I need to mark this out. Do one more thing here. Any questions before I do the other thing? So next Thursday, Master Set 07 and 08. We are going to skip the rotational motion and go to harmonic motion next. And then if there's none, we'll drop back and do rotational motion. But the next thing that we'll do will be harmonic motion. We're not at 12:20? 12:20. 12:20, okay. Oh, I want to point out one thing here. And the problem that we did, this one over here, this starts out with a momentum of 40, still up there, yep, 40 Descartes and 8 Descartes. After the collision, in the same reference frame, I know the total is 48. So afterwards, this was going to the left at 2 meters per second, and this was going to the right at 7 meters per second. So the total momentum here would be what is the total momentum of the 4 kilogram mass after the collision?
-8.
And the total momentum of the 8 kilogram mass after the collision?
Positive 56.
So if we look at the change in momentum of the 4 kilogram mass, it's going to be final minus initial, -8 minus 40. -48. For the 8 kilogram mass, it was 8 minus 56. Sorry, try that one again. 56 minus 8, which is positive 48. This would be the change in momentum of the 8 kilogram mass. And I would expect that in some sense you can look at this lost 48 units of momentum, this gained 48 units of momentum. It was transferred. This is happens under conservation, is that one is going to have some negative change, the other will have positive change. But bringing in some of the vocabulary, what was the impulse applied to the 4 kilogram mass? What was the impulse applied to the 4 kilogram mass, or imparted to? Think about the verb later. Goes back to what's impulse?
Delta.
You're fading there.
Yeah. It's the change in momentum.
Yeah, so if I'm asking what's the impulse imparted to or applied to the 4 kilogram mass, what I'm asking is what's the change in momentum of the 4 kilogram mass?
-48.
Yeah, in whatever units you want to use. What's the impulse to the 8 kilogram mass?
48.
Yep. So there's two ways of finding impulse. One is change in momentum, one is force times time, or average force times time for physics 151. Which one do you use? Whichever one you can solve using it, or whichever one you need, whichever one you have the information for. In this case, I didn't tell you force or time, so probably change in momentum is going to be the quickest way. If I said that the interaction happened for 1/10 of a second, you can find the average force. for the, if 48 is my change of momentum, if that's gonna be force times time, and I said a tenth of a second, the force is 480 newtons on average. I would like to try one other thing. Does anyone need to rush out right now? It's a non-physics related. You need to go, okay. Anyone else, can you stick around for like a minute or two?
Yeah, should be fine. Like a minute.
Yeah, all right. I want us to count to 10. The rules are, whoever's gonna speak next you can't indicate who's gonna say the next number. If any two people say the same number, you start over. And you can't do two numbers in a row. You personally cannot do two numbers in a row. And so we're gonna go count from 1 to 10. Someone begin.
1,
2,
3,
4, 5,
6,
7, 8,
9,
10,
Start over.
1,
2,
3,
4, 5,
6, 7,
8.
9.
10.
Wow, that's second try. Impressive. Have a nice weekend.
Okay.